Today's episode is proudly sponsored by the Rising Tide Mastermind. The Rising Tide Mastermind is one of my favorite things that I look forward to each and every week because I get to see people that have my best interest in mind. I know this because I have their best interest in mind. And when you get people together in a room like that, you can just imagine how people want to help other people. If this sounds like something you want to learn more about, go to scalinguph2o.com/mastermind. Welcome to the Scaling Up H2O podcast. My name is Trace Blackmore. I'm the host of this awesome podcast. Happy 2024, everybody. It's hard to believe that we are in a brand new year, but with a new year, of course, we get 12 new months that we can do annual goals. And I always talk about annual goals during the beginning of the year. One, that's the best time to do them. And I just really enjoy goal setting. And I know so many people out there in the Scaling Up Nation do the same thing. I've heard several people say that they do goal setting as a result of what they've heard on this podcast. So that is pretty darn cool if I do say so myself. And I mentioned this the last couple of episodes. I'll do it again since it's the beginning of the year. But if you have not read the 12-week year, and it's on Audible, so it's very easy to listen to, so don't interrupt your podcast listening for this podcast, but when you're done and caught up with all of these podcasts, go ahead and download Audible, and I can get you a free book and a free month by going to scalinguph2o.com/audible. And perhaps one of those free books can be The 12-Week Year by Brian Moran. I read that a couple of years ago, and I really think it's the best book I've ever read, not just because it tells you how to plan, but it tells you how to execute. And by the way, if you want a copy of that book, we've got an affiliate link for you. That's scalinguph2o.com/12, the number 12 that is, so 12-week year. And that'll take you straight to the Amazon site where you can order the book. So you might want to consider that. I will tell you my favorite thing to do at the end of the year and the beginning of the year, and that's what these last two shows have been about, is kind of assessing how the last year went and what did I learn for this new year. So it's my hope that you use this January to set up 2024 to be your best year yet. What are some areas that you want to change in your life? And then what are some goals in each one of those areas that you can change? One of my favorite books is The 7 Habits of Highly Effective People. And in Habit 2, he talks about how you create a plan for your life. And one of the things that he has you do is write down the top 5 roles that you play in your life. And if I were to think of myself, I would be a husband, I would be a father, I would be a business owner, I would be a mastermind facilitator, I'd be a podcast host. So let's go with those 5. What are the people that are involved now in each one of those roles? And I would list the people, so my wife Stacy, my son Hayden, and so on. And then I would go on to say, at my 80th birthday party, if there was a tribute party and all of these people that I just identified are going to be the keynote speakers, what do I want them to say? And that's called a tribute statement. And I'm going to write that down. And every time I try to plan a goal around one of those relationships, it is looking at that tribute statement and what can I do this week that allows them the best opportunity to say whatever I said in that tribute statement. Now, I'm not trying to make them say it. I want them to say it freely, but all these little bite-sized pieces of things that I'm going to do week after week is what's going to allow them to want to say that. And I heard that when I was 19 years old, and I didn't have a lot of key relationships like I do now. And I'm sure glad I heard that, because that really changes my responsibility that I have for the key people in my life. So I hope sharing that with you helps you learn a little bit more about yourself and how you are important in other people's lives and what you can do to make that even more important. And hopefully you can do that with tribute statements. Now, if you haven't listened to the last two episodes, they were all about, one was the end of the year, and I told you everything that I kind of accomplished with this podcast and personally. And I hope you did that as well. I hope you took the very last episode and that motivated you to do a victory lap on all the things that you accomplished last year. And I hope you learned how you accomplished those things. And even the things you weren't able to accomplish, I hope that taught you lessons so you can apply that to this year. And then last week's episode was a bit of a departure from things that we normally talk about. And we talked about relationships, and more importantly, how do we ensure that we're doing our part in conversations to always elevate the relationship? When I was planning out for that episode, I was hoping that was going to be well received, and I have received lots of feedback that people have shared that people have re-listened to it, people have had their spouses listen to it, and all sorts of in between. So with that, I want to thank the Scaling Up Nation for taking seriously our responsibility with all of our relationships. And it all starts with kindness and kind words, and how do we lift each other up. And just think, if we all did that, it would be a totally different planet. And there's no reason that we can't all live on that planet. And it starts with you. It starts with me. And with us doing some of the things that we talked about in the last week's episode, we are now able to be part of that solution. So that's a world I want to live in. I know that that's a world that's a lot better than where we are currently at, especially if we look at certain sides of, or different sides of areas. I don't want to specifically say politics, but it's hard not to when we see how we're just arguing about things and not actually getting things done. There's a reason we do things, and I think we need to put that reason in front of all of our personal gain. But I will get off of that soapbox, and all that to just say thank you for all the people that listened to last week and shared last week. That really means a lot to me. With that, let me share some more things with you, because one of the things people tell me all the time when I see you at trade shows and different conventions is they love that there is a one-stop place that they can go to learn everything that's happening in the water treatment industry. So we normally tell you about a few items, and then you can go to our events page on scalinguph2o.com. and you can learn everything that is going on in our industry at a glance. And the team at Scaling Up H2O has just done a great job with that. They went ahead and put everything that they could find about our industry in the events page. And you can simply click not only to go to that event and register, but also click and put those events in your calendar. They made it super easy. What a great team we have here at Scaling Up H2O. But here's some events that we can talk about right now. The 2024 Annual Conference and CTI Expo, that's the Cooling Tower Institute, is having their conference in Houston, Texas, February 4th through 8th. We've had several guests that have spoken at the CTI conference, so maybe this is something that you want to look more into. And if you're in the same type of water treatment that I am, this is an organization for you. And it's all about environmentally responsible evaporative heat transfer. So that includes cooling towers and cooling technology all over. So we'll have that information on our events page so you can check that out. And while you're there, you can look at the Membrane Technology Conference taking place March 4th through 7th in West Palm Beach, Florida. That's actually where I got married, in West Palm Beach, Florida. Not that you needed to know that, but I just wanted to share. So this is a conference that explores the latest developments in membrane technology. So if this is something that you want to learn more about, and it's hosted by the American Waterworks Association, you can go to our events page and we'll have all of that laid out for you right there. If you are in Vancouver, Washington on March 15th and 16th, you can go to the 2024 Pacific Northwest Groundwater Exposition, and we'll have all of that information for you on our events page. And the last event is the 2023 Water Week taking place in Washington, D.C., April 7th through 13th. Water Week is supported by a broad group of partner organizations that offer a sector of opportunity to advance in policy priorities for clean and safe drinking water. So with that, if that is the type of water treatment that you practice, you might want to check that out. Talking about events, yesterday we just had our first quarter hang, and I have to say, I love the hangs that we do because I get to meet so many people within the Scaling Up Nation. And thank you for all the people that joined us on the hang. We always have a good time. And if you want to join us on the next hang, and of course you do, the hang is where we get to network, where we get to meet each other, where we get to solve potential and future problems, and we just have fun. So the next one's going to be April 11th at 6 p.m. Eastern Time. It's exactly for 1 hour. I promise it would be worth the hour that you invested. And I promise if you come to one, you're going to come to the next one. So I look forward to seeing you on the hang. And to register, you can go to scalinguph2o.com/hang. Once again, that's scalinguph2o.com/hang. Well, last week, we learned all about reverse osmosis with James McDonald's new segment, Drop by Drop with James. So here is our latest installment.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment, you guessed it, drop by drop, together. In today's episode, we're asking, what if? What if a cooling tower's blowdown valve gets stuck open? What would happen? Sure, the conductivity would probably start to drop. Would the cooling tower basin be completely drained? Why or why not? What is the size relationship between the makeup water line and blowdown line? Is there one? What could cause a cooling tower blowdown valve to get stuck open? How could you diagnose this problem remotely? How could you be alerted to this problem remotely? What would you recommend to recover from this situation? What would be the impact upon the water treatment program if the blowdown valve for a cooling tower got stuck open? Are some valves more susceptible to failure than others? In the event of an electrical failure, should a cooling tower valve be chosen that fails open, closed, or last position? These are some things to think about when asking yourself, what if? I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
Scaling Up Nation, I love it when I am introduced to people I have not yet met. And our next guest is an example of that. A listener of the Scaling Up H2O podcast said, this is a guest that you need to interview. And we did that, and I know you're going to love the interview. Here it is. My lab partner today is Loraine Huchler, founder and president of Martech Systems. Welcome, Loraine.
Well, thank you. It's great to be here.
We are very excited to have you here on the Scaling Up H2O podcast, and I can't wait to talk about the paper that you presented at CTI, the Cooling Technology Institute. But before we get there, do you mind telling the Scaling Up Nation a bit about yourself?
I am a chemical engineer by training. I actually didn't start in water treatment. I started in gas turbine engines for aircraft. And the defense industry was declining after Reagan left office, so I went looking for something else, and I worked at water treatment companies, and after their first merger, I decided it wasn't any fun, so I became an independent consultant. It's year 26, and my practice ranges from heavy industry, manufacturing, large-scale comfort cooling and heating systems, everything about water, mostly utility water, and it's been a great ride. What can I say?
When I speak with people, one of my favorite questions to ask is how they actually found their way into water treatment, how they even know that this was a career choice. I'm curious, what was your story?
I had worked in defense. In fact, I worked for General Dynamics doing F-16 engine aircraft integration, and I did not want to live in Fort Worth, Texas anymore. So I came back home to New Jersey and went looking. I wanted a marketing job. And I went into technical marketing where we were doing field trials of new chemicals. We were writing marketing collateral, and I just kept interviewing. I looked at compressed gases, but I knew I wanted to be in something where I was in technical marketing. They were selling a product and services.
Was it an ad you saw? Did somebody let you know there was an opening available?
Yes, I went and interviewed, and surprise, surprise, I got the job, even though I didn't have any marketing experience.
And history was made.
That's right.
Well, fast forward to not too terribly long ago, you decided to write a technical paper for the CTI conference, and it's fascinating. I'm going to make sure we put it on our show notes page so people can read it just like I did. But to get us started, what problem were you trying to solve, and how did you get involved with what you were actually doing?
Let's start with how I got involved, because I had been working for a large commercial management firm, commercial real estate management firm, on their heating and cooling systems. And I got a referral in, and they said this individual is an entrepreneur. They're developing this novel technology. They're in Washington, D.C. Suburbs. Would you go and visit with them? And, my consulting practice is really about risk management, and Legionella risk management fits there perfectly. I mean, my whole approach is managing risk. And I went down, and they were showing me this device using some kind of electromagnetic or electrostatic, and they were doing scale reduction. And over in the corner was this other device. I said, "What's that?" I said, "That's our non-thermal plasma. We think it will kill bacteria." I said, "Oh, like Legionella?" "Yeah." And so we're talking. I said, "That one's really much more interesting than your scale reducing device." And so on that kind of hint, they switched gears entirely, and that must have been about 6-8 years ago. And they did a lab study. They bought a cooling tower and installed it, and they ran a laboratory study on a cooling tower. And in 5 days, they proved that the technology had efficacy against all kinds of bacteria. They didn't actually have Legionella bacteria, and so I went looking for a client who might be interested in, doing a full-scale investigation. And one of my past clients, I used to refer to him as kind of a mad scientist. He was intrigued by all kinds of technologies, and half my consulting work with him was trying to guard against him getting flim-flammed. Like, that doesn't make sense. Let's put him on the back burner. But he agreed, and we installed the device, and the pandemic hit. So we had to wait for permission to get back in. And I did get in during the pandemic. I think it was June of 2021. We were able to get back in and commission the equipment, and I started the trial. It was a 6-month trial.
And it actually turned out to be a pretty good time because when you are trying to grow Legionella, you don't want that many people around.
Exactly. The only people on site were a couple, the facilities group, and they had an outsourced facilities management group that was maintaining the building. And so no one was parking on the parking deck next to the cooling tower. And you had to bring your lunch because the cafeteria was not open.
Not a lot of things were open during that time. I did not say the actual title of your paper. So it's technical paper 2224, Managing Legionella Using an Innovative Bacterial Control System and Rapid Genetic Legionella. So with that, I'm curious, tell us about the device and what was your hypothesis as you started this process?
So the device it uses 3 different technologies in order to control bacteria. It has the non-thermal plasma. Remember, plasma is the 4th state of matter. We might have learned that in science class. We have liquid, gas, solids, and plasma. That's an energized gas. And I actually saw one commercial application of trying to remove bacteria from used lubrication oils. But otherwise, it is unknown in the world of water treatment. So the non-thermal plasma has a device, and a side stream of the water from the cooling tower has to pass through the reaction chamber, and it's exposed to these filaments of highly energized gas, because when the high electrical discharge hits the water, it actually makes little small concentrations of oxidizers. It makes UV light, it makes ozone, it makes chlorine dioxide, because you're just using potable water. And it actually will destroy any bacteria that touches, but there's this field around it, and we see that bacteria that aren't actually killed are wounded. They can't reproduce. And many of those are gram-negative bacteria, which often will convert as they mature to sessile form. So the turnover time was probably about twice a day. It would see every molecule of water. That's important, because if you don't put enough dosage in, then you're not going to be able to control. The second technology was copper silver ionization, and we usually think about that in potable water systems. It's been tried in cooling water systems, but by itself, it isn't very effective. There's just too much bacteria and too many suspended solids. But when it's paired with another technology, it has such good efficacy on penetrating biofilms. The copper actually will lyse the cell membrane, and the silver will enter the cell and poison it, and it will penetrate the biofilm. The third technology was oxidizing biocide, a mixture of bromine and chlorine. They did an innovative in situ electrolytic production of sodium hypochlorite from salt to avoid exposure. And we happened to use during the trial liquid bromine, but ideally you would want the pellets to convert to solubilize so that you would really minimize any exposure to oxidizing biocide. So all of the bacteria that was liberated from the biofilm, whether it was live or dead, the oxidizing biocide would kill that bacteria in the bulk water. So it was a perfect scenario. I'd like to think of it as a war where you have bombs and you have missiles and you have bullets. So, each one has a different purpose, and, penetrating that biofilm is essential. If you have no biofilm, you cannot have Legionella, because it needs a higher life form to reproduce. It's a parasite. So in that biofilm exist amoebas and protozoas, and no biofilm, no Legionella reproduction.
So you're actually taking the biocides that you mentioned and charging them to that plasma state?
No, the non-thermal plasma reaction chamber was first.
Got it.
Right. And we actually just suspended all of the biocides at the start of the trial. It took 10 weeks to grow Legionella, because it was a relatively high altitude and cool summers. But we did it.
So I'm curious, most of us try to go the other direction in producing Legionella. What were some of the techniques that you were employing to try to grow Legionella?
Well, obviously, first of all, suspend all biocides, and there's an algicide there. And so the chemical supplier, to his credit, he must have thought I was really trustworthy, because he said, "Sure, we can do that." Now, his upper management didn't really think that way, but he was intrigued. And so we suspended his oxidizing biocide, we suspended the algicide, and then we would dose at very low concentrations of our bromine chlorine mixture, just because we felt like we really needed to manage biofilm, and we did not feed any algicide. And then I was there every other week for 2 or 3 days on site, testing for Legionella, testing the water quality. And we had remote monitoring, so that was great. And we had remote control, so we could adjust the dosages of anything remotely. But I was out of town on the week, it was my week off, and I got a frantic call. And the facilities manager said, "We have a high temperature alarm in the chiller, on the chiller side, the closed side." They said, "What's going on?" And I said, "I know exactly what's going on." I said, "Forget about the trial issue. Feed the biocides, your normal dosages. This was Thursday. I'll be in on Monday." And we forget that if Legionella needs biofilm to reproduce, that biofilm is so insulating, 4 or 5 times as insulating as calcium carbonate. And so we had built up such a large layer of biofilm that we had inhibited heat transfer to the point where the water temperature was 95 degrees in the chilled water side. That's supposed to be 95. So I came in on Monday and we had over 300 CFU per milliliter of Legionella, because we had the field Legionella tests. Within an hour, I could get a result. And so I said, wow, here we go. Took 15 days. We were kind of playing around with the dosages. We kept the non-thermal plasma device on, but we were adjusting. But it took 15 days to reduce the population to below 2 CFU per milliliter. I thought that was not bad.
I'm curious, what were some of the testing methods you were employing with both testing the water as well as testing for Legionella?
Well, we did the basic testing for conductivity and pH. We weren't testing for corrosion control additives, simply because it wasn't relevant to the study, and the water treatment supplier was fully in control of that dosing and measuring. But we used ATP, which really did not tell us all that much. We used the standard dip slides. We know it does not correlate, general bacteria, aerobic bacteria with Legionella. And then we used 2 field qPCR tests. Normally, and we did send it out to a lab for culture as well. So we do show some culture results in our paper. But the qPCR tests, the merits of those tests is, number one, they're fast. You get results same day. So it allows you to do feedback control. You know how you're doing. We can't use laboratory tests for feedback control because it's a 2-week process. And we had 1 manual test and 1 online test. And so the manual test, there's only one. It's out of Canada. It's Genomodex. And it's a really interesting device. I call it like a busy box, but it has all the reagents in syringes, including, chaser water to make sure that you're flushing the sample in. You put your 100 milliliters of water into the device and it filters it, all the suspended solids out. And the bacteria go through the filter, and now it needs to concentrate the bacteria and make it, the process is amplification. So you put the reagents in and in the reaction chamber to do the sample prep. And then you actually push a button and it takes the bacteria, the biological material, and puts it into this tiny plastic cuvette. And the cuvette, you have to pull out the bottom and put it into the, what do they call it? It's not an incubator, it's the replicator. So it's a thermocycler. And so you put it into the device and you hook it up to the computer, and the computer controls the thermocycler time. And then it transfers the data on the concentration of Legionella to the computer. So it takes 1 hour. And remember, you're not using colony forming units per milliliter. Instead, it's a different metric. And so, interestingly, Canada says the qPCR results are exactly equal to the CFU per milliliter for specification limits. I don't know if that's true, but in the paper, some of the graphs will show you the bacteria counts from the laboratory, and others will show the results of qPCR. And then we had an online qPCR device, which was, again, remote controlled and same concept. Of course, they claim that their qPCR technology, it's different for every company. So theirs was very sensitive. We could get down to 1 or 2 relative light units, but that one took 4 hours because you had to flush your transfer lines, and you could remotely ask to program. There were 15 tests per cassette, and then you would have to manually go and replace the consumables. But we ran both side by side on the second half of the study, and it was just wonderful to be able to have so much data and to verify the population of Legionella instead of and compare it to the lab. Right? Remember, the laboratory studies, there's a risk that sample that you ship, even on ice, changes. And of course, I already mentioned you can't do feedback control. But I had a great time. I was learning so much every day.
Did you know which species of Legionella you were growing in the tower?
It was pneumophila, and most of the time it was serogroup 1.
The tests that you were using on site, would they tell you what species, or they just test for all Legionella?
The field tests test for all Legionella, but in the lab, you can differentiate. So
a lot of people are using the field-based tests to do exactly what you said, where we've got an issue. Let's try to figure out where that issue is coming from, because now we can get quicker data. And then when things are back under control, they'll send that sample off to the lab to get that final verification. Is that how you've seen those things used?
I have never seen them used in the field. In fact, I had heard that one water treatment company bought 100 of the manual tests, but I talked to some of their field reps, and they said, we've never seen that device. So no one knows about it, or no one had known about it. And I think it's worth every penny.
I'm curious, what did you learn about biofilm during this process?
Well, I learned how insulating it was. I really had not even given it a thought, but the biofilm is mostly water. And so water is very insulating. Think about the boundary layer. You want high turbulence so that you don't have insulation from water. I learned about how variable Legionella population would be because it has to be released from the biofilm after it reproduces. And so, the measuring day after day, one day it might be 200 and the next day it might be 70. Highly variable. And so, when we're used to looking at calcium concentrations, and they rise and fall, with a long period, not like Legionella. Today you have it, and tomorrow you have tons of it. But the challenge with biofilm is nobody measures it. I mean, there are some techniques to measure biofilm, but I don't see them in comfort cooling and heating systems. I mean, I shouldn't say heating, but some heating systems, when they're idle, they have biofilm. And the simplest method is to take your bypass corrosion coupon rack for your cooling tower and put a stainless steel mesh coupon in, metal mesh, and capture biofilm on that coupon. And you can touch it, the empirical approach, or you can sonicate it and do a bacteria test. You can even look at some of the biodetectors that will show you field tests that you can see some what would I call it, sessile bacteria, and I don't see that being used. And yet it's so easy because you've got your corrosion coupon rack on any tower of any significant size. If you can't see it, if you can't measure it, you can't manage it, and this is the challenge, right? Nobody manages it because they don't measure it. And they don't even, the facilities people, they really don't think about biofilm.
It's an afterthought until they get that alarm, and then they call you.
So I'd be interested to hear people's feedback on the device known as a BioGeorge. It's a piezoelectric device. I don't have any personal experience with it, but from my time working inside a water treatment company, and this, of course, was over 20 years ago, but the conversation was that sometimes it works and sometimes it doesn't. And Lord knows if it's based on the location because it's an online device, or the maintenance of it, or the interpretation of the data. But that device is continuous, and you can get a signal and kind of track the trend of biofilm, and that would be very helpful because now you get real-time feedback to try to manage it.
What was the overall conclusion you made from your paper, from your research?
Well, the big takeaway was it works. I mean, on week 9, when I couldn't even grow Legionella, I was beginning to despair. Is this a fool's errand? I can't even get to first base. But, we put it through its paces, did several rounds of grow Legionella, kill Legionella, grow Legionella, kill Legionella. And it was clear to me that with that feedback control, you could really tune your system. And you could, towards the end, I mean, I know it was colder temperatures and Legionella doesn't thrive as the temperature decreases, but we could consistently, day after day, test after test, be below 5 and definitely below 2 for most days.
I'm curious, were there any tests done to the plasma device without the biocides you were using?
Yes, yes. We've started with just non-thermal plasma, and then we added on copper silver, and then we added on oxidizing biocide.
What did your data show as you did that?
Well, it showed obviously better efficacy the more modalities you used, treatment modalities, but I was surprised at the efficacy of the non-thermal plasma. Because remember, it's turnovers twice a day. It's a side stream. The filaments have to actually contact bacteria to kill it, and they'll wound the ones around in the electric field. But I was really surprised because what we saw with the paddle testers is one side was total aerobic bacteria, but the other one was gram negative. And that really helped us to see that gram negative bacteria was decreasing. So that was a surprise to me.
Was there any way to measure how far the plasma went in the system? Or did it totally recirculate? Did it lose its...
No, no, no. When it left the reaction chamber, it was no longer plasma. Very short-lived.
Any data that helped with low flow, dead leg areas where we have those problem areas where Legionella likes to hide out and we can't get to it?
Yeah, the only possibility is that the copper silver ions will disperse into the dead leg. I mean, dead legs are a known hazard for Legionella growth. I have one client who he was on a rampage. He was systematically eliminating any dead leg in his system. A noble goal, but simple to do, but takes a lot of focus and effort. So I'm not confident that that is the only way to manage it.
What do you want the water treaters listening to this podcast to do with the data that you presented?
Number one is to gain an awareness about alternative treatments and the fact that the current treatment may not be the most effective option. I mean, if you think about what is the precision for feeding non-oxidizing biocides? I mean, I've always wondered, like, how do you know the right dose? You don't measure sessile bacteria, so it's twice a week in the winter, in the shoulder seasons, and 3 times a week in the peak season. Where'd that number come up? I mean, I don't even see any empirical basis for it. I'm not a water treater. I never was. I was always, behind the scenes. But this is a challenge. If you don't control sessile bacteria, you're not controlling the risk.
Where do you want to see water treatment going, say, in the next 10 years?
I would love to see automation. I mean, the systems the systems that were at that site, completely manual adjustment, no feedback control, not on anything. we don't have feedback control on non-oxidizing biocides, but certainly everything else can be automated. Online analyzers, testing for sessile bacteria. It's simple. At least have data. And, it's not just about water treatment. It's about what your customer or client does. I mean, are they doing routine maintenance if something breaks, right? Are they cleaning the tower? Are they washing the louvers? Are they cleaning out the basin? What's their idling strategy? Are they dosing with biocide before they lay it up? When they inspect a chiller, if this isolation valve doesn't hold, they might drain a significant amount of water and then they refill it with water but no chemicals. So it's a full court press to manage these systems, both for Legionella risk management but also reliability. It's not glamorous.
Hindsight's always an amazing thing. From all of the things you learned through this process, if you had the opportunity to go back and redo this study, what would you do different?
Oh, that is so good. I know exactly what I would do. I would go get one of those model heat exchangers. They sell them commercially, and many of the water treatment companies have them in their own arsenal to use as a tool. But you can match the tube wall thickness and tube design, and you take a side stream of the cooling water, and you at time zero that tube is perfectly clean, and you're putting heat on it, and now you can watch the biofilm form, and you can watch the heat transfer efficiency drop. I mean, Legionella can be a very unpopular conversation, especially at cocktail parties. But when you start talking about if you control biofilm, you control Legionella, but is a bigger bonus, and it's money, real money, which is electricity for heat transfer efficiency. Now you've got something. You basically get two birds with one stone. So I think the message has to be about biofilm causes a lot of problems, health problems, but it also is increasing your operating costs.
Were you able to collect any data about how your procedure affected corrosion within the system?
I mean, they have corrosion coupons. It's rather a gross measure. My sense, though, is that we were dosing oxidizing biocide at much lower doses than the incumbent water treater. And both of them were shot feed, but we were systematically shot feeding, and then feeding again during the same day, perhaps. It was a much more frequent dose at lower concentration. So we were mindful about the risks of shot feeding oxidizing biocides. But again, the corrosion coupons, they met spec. I mean, it didn't tell me much. Now, if we had a correlator online, I think we could have gotten some more information. But big picture, the corrosion rates from that study were probably less than normal operation.
What's the bottom line that you want to get across in this interview?
I think there are a lot of tools and understanding to manage both these issues, Legionella and heat transfer. I think the mental models are so important to think about. The technical literature talks about Legionella in particular, but doesn't really get into the details about which things are most important to manage the risk. Sometimes it's not water treatment at all. It's what the owner does to, maintain the cleanliness of the system and idling it properly. It's where the rubber meets the road.
Well, Loraine, with your permission, I'd like to put your paper up on our show notes page so people can read that as they listen to the podcast.
That would be great.
So thank you for that. I do have a couple of lightning round questions for you if you're ready for those.
I'm ready.
All right, so if you could go back to your very first day as a chemical engineer, what advice would you give yourself?
I think about my own career, explore other opportunities, particularly if you're discomforted like I was. Don't think that's a negative. It's an opportunity to think through, take some risks, and believe in your abilities. Don't let your employer map out your career. Chart your course. How else would I have built a really nice consulting business, wrote a book, and I've traveled the world. Some places I won't go back, but it's not a vacation.
Tell us about your book.
Oh, it is about influent water, clarifiers, filters, demineralizers, softeners, and reverse osmosis, or actually membrane filtration. And it's really designed for people who are not experts in water. It's probably the best audience is an operator or an early career engineer who doesn't know anything about water. It's a very practical book, tips and tricks. It was really a lot of fun to write.
Well, speaking of books, what are the last few books that you've read?
This is an interesting list, an eclectic list. I read Woke Incorporated by one of the presidential candidates, Vivek Ramaswamy. Very interesting insight into corporate America. I'm a big fan of Tom Clancy. I read The Sum of All Fears. Now that, unfortunately, is a little bit of a mirror of what's happening in the world today. And the last one might surprise you. I'm reading the book Companions in Christ, which is a discipleship training. And we meet as a group to work through that book. Very good book.
So my last question for you, if you could talk with anybody throughout history, who would it be with and why?
I grew up Catholic, but I would love to talk to Martin Luther because he was a Catholic priest that challenged the moral authority of the Roman Catholic Church. And his conviction that the Bible is a central religious authority and that we're saved by faith, not works, made it possible for people to have this personal relationship with God. And I find that such an invigorating path forward for religion. Really change the world.
Well, I really appreciate you coming on the Scaling Up H2O podcast. Thank you for not only the paper, but all the information that you've given to the water treatment community.
Thank you. I love it.
Scaling Up Nation, as I mentioned at the top of the interview, I met Loraine by having somebody reach out to the Scaling Up team and saying, this is somebody that you need to meet. Not only did I get to interview Loraine, I also got to meet her in person when we were at the International Water Conference this past November. I had the distinct privilege of being the keynote speaker at that event, and that was just so cool. I'm looking forward to doing some more keynote speaking, and I got to attend several of the technical papers there at the International Water Conference. Loraine actually gave a presentation, and Loraine is methodical. She makes sure that all her T's are crossed and I's are dotted, and I really enjoy reading her papers and listening to her present because she is just very factual and she anticipates what people are going to ask. So she's a very good presenter. So not only did I get to experience that, several presentations, Loraine and I sat next to each other. And as the presenter was talking about stuff, we were kind of able to give each other some extra information back and forth to enjoy that presentation even more. So thank you for introducing me to Loraine. And Loraine, thank you for coming on the Scaling Up H2O podcast. Early in the show, we heard James doing his drop by drop, and I mentioned last week he covered reverse osmosis. So I do want to go ahead and mention one of my reverse osmosis heroes is Jane Kuchera, and that is episode 339. So if you want to learn some more about reverse osmosis, 339 is definitely the episode to do that. And Jane has just come out with a third version of her reverse osmosis book. It is the end-all be-all of everything you would ever need to know about reverse osmosis. And not only is it printed there, Jane puts so many resources, so even as the information changes, you know where to go to get that information. It is by far one of my favorite reference books. And if it's not on your reference shelf, You probably want to make it part of your references. So we've got an affiliate link for you that is scalinguph2o.com/RO. And I think every company needs to have this on their bookshelf to make sure that when you have RO questions, you've got a great resource to go to. Of course, that's after you listen to episode 339. But I just have to say, it is such an honor and a pleasure to be able to host a podcast where I get to meet so many great people like Loraine, like Jane, and do things like be the keynote presenter at the International Water Conference. That is just such an amazing honor, and I get to meet so many people. So I want to thank the Scaling Up Nation for listening to this podcast each and every week. And by making sure other people know about this podcast, we get to meet more people, we get to do more things, and of course, we're going to have more topics for you each and every week. If you know a topic that you want to talk about on this podcast, maybe it's you, maybe it's a guest, maybe it's just an idea you have, whatever it is, please share that with us. We are always looking for ideas for the show, and you can go to scalinguph2o.com, go over to our show ideas page, and then that will make sure that when we're talking about what are we going to talk about next, we have your idea in front of us. The Scaling Up Nation has kept us going 7 years strong. We're going to hit 400 episodes by the end of this year. The only way that we are doing that is we are in this together. So thank you for helping us make sure that this is the best water treatment podcast out there. Scaling Up Nation, I can't wait to bring another new episode to you next week. Until then, take care, folks. Scaling Up Nation, it's my hope that whatever you do in the industrial water treatment community, that you do it with excellence. And if you're in the same type of water treatment that I'm in, I do that by maintaining my Certified Water Technologist designation. I know so many of you out there are studying for that prestigious certification, and I'm here to help. I've answered each one of the mock exam questions, letting you know the logic behind how questions are asked, and also doing all the math to show you how to set things up so you can easily find the right answer and make sure you don't select one of those sneaky wrong answers. Go to scalinguph2o.com/CWT prep. Again, that's scalinguph2o.com/CWT prep to sign up today.